Hello everyone. In this tutorial, we will see the role of deep learning layers. So a layer, basically a layer in a deep learning model that serves a fundamental building block in the model's architecture. So basically, the layers are the fundamental units in a deep learning model working together to process the transform data, and information flows through layers one after another. Each layer takes input from previous layer, process it, and sends it output to the next layer. And layers perform specific computations, introducing non-linearity and creating some abstract representations of the data. And layers extract features and patterns from the data, building on the work of previous layers. And different layer types exist, each with a specific function within the overall network architecture. And after that, the nature and the function of the layer, basically a layer vary based on its type within the neural network architecture. For instance, if it is dense, I mean the fully connected layer, neurons in this layer are connected to every neuron in the previous layer and creating a dense network of connections, and this layer is effective in capturing global patterns in the data. And convolution layer, basically this specialized for grid-like data and such as images. This layer employs convolution operations to basically detect spatial patterns and features. I mean the hidden patterns and the features. And recurrent layers suited for sequential data. Recurrent layers utilize feedback loops and consider context from previous time steps, making them suitable for tasks like NLP, natural language processing. And the pooling layer reduces it basically reduces spatial dimensions and focuses on retaining essential information, aiding in down sampling and feature selection. And after that, it is basically it's a very we also saw that in our previous lectures, the activation functions are the major part of deep learning model, any deep learning model. So activation functions, various type of activation functions are there. That is the step function, sigmoid function, ReLU, leaky ReLU. And we basically step function. What is step function? The step function is one of the simplest kind of activation function. In this consider we consider basically a threshold value, and if the value not I mean value of net input, say y, is greater than the threshold, then the neuron is activated. So mathematically we see that fx equal to 1 if x greater or equal to 0, and fx equal to 0 if x less than 0. As simple as that. And sigmoid function, basically sigmoid function is a widely used activation function, and it is defined as basically 1 by 1 plus e to the power minus x. And this is a smooth function, and it's continuously differentiable. So the biggest advantage that it has over step and linear function is that it is non-linear. This is an incredibly cool feature for the of the sigmoid function. This essentially means that when I have multiple neurons having sigmoid function as their activation function, so the output is non-linear as well. So the function ranges from 0 to 1 having an S shape. And mostly used in any deep learning model, the ReLU function. The ReLU function is the rectified linear unit. It is the most widely used activation function. It is defined as fx equal to max of 0 comma x. And the main advantage of using the ReLU activation function over other activation function is that it does not activate all the neurons at the same time. What does it mean? If you look at the ReLU function, if the input is negative, it will convert it to 0 and the neuron does not get activated. And the extended version of ReLU is leaky ReLU. So leaky ReLU function is nothing but an improved version of leaky ReLU function. And instead of defining the ReLU function as 0 for x less than 0, we define it smaller, so small linear component of x, and that is fx equal to x if x less than 0, and fx equal to x otherwise. And after that, uh, activation functions, I mean in PyTorch, what is activation function and why to use them? right? We should understand that why we basically use the activation function. Basically, uh, mimic how neurons in the brain process the information, it basically means. And it basically function is the applied to weighted sums from previous layers. And uh, and the purpose of this for using this activation function is introducing non-linearity for complex relationships, and differentiable allows basically error back propagation for weight adjustment. And it basically found in the torch.nn library. And types of pytorch activation functions are like ReLU. We saw that ReLU activation function, leaky ReLU, sigmoid, tanh, and softmax activation function that is widely used in our deep learning models. We will see in our upcoming videos. So that is so in this video we saw some activation functions and deep learning concepts, critical deep learning, main deep learning concepts. So thank you guys.